Thank you. Good afternoon, everybody. Awesome. Thank you so much for being here. I'm looking forward to being here at PyOhio 2018 and to talk to you about better testing. There's so much I could say about this topic. We're basically going to be looking at the very tip of a very large iceberg. So just FYI, there will be a little bit of code in this talk, but it's primarily going to be focused more on testing and automation practices than on code implementation. So a little bit about myself. This is me at PyCon 2018. Yes. My name is Andy, and I am a software engineer in test. I have a lot of expertise with testing, automation, behavior-driven development. Right now, I live in Raleigh, North Carolina. I work for a small company called Precision Lender, a very fun place. I encourage you to check it out. I went to RIT up in Rochester, New York, class of 2010, and I'm an avid Pythoneer, as I'm sure all of you are as well. Be sure to follow me on Twitter at AutomationPanda. I also blog at automationpanda.com. And there will be resources up there from my talk today. So here's an icebreaker question. Raise your hand if you have ever hit a software bug. Woo, hands up, right? It could be that you discovered it, maybe you even caused it, right? But we all have experienced the software bug. Right, cool. All right, so now, raise your hand if you always test your code. Ooh, indictment against humanity there. That's okay, we got some people, right? So, now the third question. Why don't we automate those tests that we know we should be doing, right? We all know we've hit bugs. Everybody, two hands in the air, right? We know we should be testing, and we know we should be automating those tests because that gives us great protection for our product. So why don't we, right? Let's have some real talk about this. First of all, we know that test automation is necessary in modern software development. Things move fast. Things move faster than ever before. Facebook uses a direct push from master in their continuous deployment system. They're deploying hundreds of times a day. I mean, even back in 2011, I think Amazon was bragging that they would deploy every 12 seconds, right? We live in a fast-paced world, and there's simply no time to run manual tests, right? The tests need to be automated so that they can run in continuous integration. Second, we also must recognize that test automation isn't that easy. If it were easy, we'd all be doing it all the time, right? Test automation is a hard problem. It's challenging. It's not just, quote unquote, writing test scripts. That grinds my gears when people say that. It requires strong software development skills. It requires its own stack. It has its own design patterns. It has its own tools. And it's also hard to keep your tests up to date with ever-changing features, is it not? Change something in the product, what happens? Boom, test fails, right? Is it because there's a bug? Not necessarily. Maybe the test is now out of date. Ouch. So it's challenging. It's not an easy thing. Third, test automation can also be intimidating, right? Let's be honest, the typical developer often lacks test automation skills. Not because they're incompetent or incapable, but because that's not where their expertise lies, right? Test automation and testing in general is its own specialty. A lot of times we see two different situations on teams. Either they haven't been doing test automation because they've had higher priorities, and when it comes time that they start thinking about it, they've become overwhelmed, like, oh my gosh, I have no idea what I'm doing. Or you have other teams that have tried test automation, and for lack of a better word, failed. They have thousands of tests that crash and burn all the time and don't really add any value back into the business and development process because they weren't implemented right. Neither one of those situations is good. And that's when we hit this moment. Egad! Right? You get that Egad moment. What do? We're stuck in a bad situation. We know we need tests. We don't do tests. We want to do tests. We don't know how to do tests. Ah! Right? What do? Well, it's okay. You're not alone. You're not alone. Let's meet somebody who can help. I'd like to introduce you to my friend. This is Amanda the Panda. Hi, Amanda. How are you today? Amanda is a software engineer who loves using Python. Amanda works at Bamboozle, a small but growing tech company. Bamboozle provides an online platform for Panda commerce. As a full-stack developer, Amanda has a good understanding of Bamboozle's web front end, their REST API service layer, and their infrastructure needs. She's very talented. Recently, though, Bamboozle's had a couple pretty big bugs escape to production. Ooh, bugs, right? Management decided it was finally time to address this Egad situation and get some test automation in place so that that doesn't happen again, or rather, that it happens less often and gets caught earlier, because mistakes always happen. And Amanda, the good girl that she is, has volunteered to lead this effort. Since this is her first time that she's doing test automation, Amanda does her homework. She goes on Google, tries to search some stuff. She learns about different types of testing. She learns about different tools, different frameworks. However, her web research feels more like a game of Buzzword Bingo. She's finding all these big buzzword terms. There's so many catchphrases. It's just overwhelming. And what's really frustrating is that people give different definitions to each of these words. What's the difference between integration tests, end-to-end, functional, system? Are there differences? Are they the same thing? Why are there so many different frameworks? Do I really need packages like Selenium WebDriver and Cucumber? Egad! She has no idea what's going on. It's hard. So, Amanda calls her friend, Andy the Panda. Andy is a software engineer in test. I'm Andy. There's a cucumber on my head. Ha 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 ha. Right. Inside joke. Let me know if you can figure it out. So she calls up Andy. And she says, Andy, there's so much information out there. Where do I start? I want to do things the right way. That's the big concern. There's many ways I could do something. I want to do things the right way. So how do I do things the right way? What is the right approach to take? So Andy asks her back, let me ask you a question. What is your main goal with testing? Well, Amanda replies, I guess I want to make sure that the critical parts of the Bamboozle app are working correctly. Anytime somebody introduces a bug, tests should catch it immediately. Great, Andy says. It sounds like you need a functional test automation solution. Functional tests make sure that features work correctly. As you said, functional tests serve two main purposes: validating goodness and identifying badness. I'd like to show you the testing pyramid. Has anybody seen this before? Yeah, some people. Boom, other people's new. Let's go over this. I'd like to show you the testing pyramid to help you put some pieces together. The pyramid is a rough guideline for how an automation solution should be structured. All layers are functional tests: unit, integration, end-to-end. At the bottom, we have the unit tests, which cover individual units of code. They could be testing methods, functions, classes. Unit tests are inherently white box, because they have direct access to the code that they are testing. Above unit tests are what we call feature tests. These would be your integration tests, your end-to-end tests. You might also call them system tests. I don't want to get too hung up on words here. The feature tests will cover black box scenarios because they're testing real live instances of the product or products under test, right? It's black box because they don't have direct access to the implementation code. They're interacting with it as, say, an end user or consumer would be using it. Integration tests are where we cover tests where components meet together, usually something like service testing. And end-to-end tests are going to be longer versions of integration tests where you're testing a path through the system. Typically, that would be web UI tests because they need everything underneath of it to power that app. Each layer in the pyramid mitigates risks at its optimal return on investment. We want a strong foundation of unit tests because they are small, quick, and easy to maintain, and they're also as close to the code as possible. Integration, and especially end-to-end tests, are far more costly to build and maintain. And they also take much, much more time to run. Consider the rule of ones. Unit tests, on average, take about a millisecond order of magnitude to run. Integration service tests will take about 1 second to run. And end-to-end web tests usually take about 1 minute to run. It's big, big stakes when you have hundreds to thousands of tests in your solution. Hold on, Andy, Amanda interjects. Why do we even need feature tests? They sound like such a burden when compared to unit tests. I also read that web tests can be really flaky. Andy replies, well, unit tests don't catch all problems. Here's an example. Back in 1999, NASA lost the Mars Climate Orbiter when it disintegrated in the Martian atmosphere. Why? Ground-based software did not convert US measurements into the metric system. Oops. The calculation modules worked individually, but they did not integrate properly. Had NASA checked that software with proper integration tests, they would not have lost $655 million. Wow, Amanda exclaims. I wouldn't want that to happen to Bamboozle. Sounds like I need to take a pyramid approach. That you do. So, what skills do I need to get started? Good news, Python. You already have the skills. Test automation is software development, and the same development principles apply. Just pick a core framework and get rolling. You may also want to take some online courses about frameworks and tools that you think you'll need for your test automation solution. So there's another question Amanda asks. What framework should I use? Bamboozle uses a lot of Python on the back end. So I looked into frameworks like unit test and pytest and doctest. There's one out there called avocado. Which one would be best? Python is one of the best languages for test automation, Andy replies. And you can't go wrong with pytest. Yeah, pytest. You can't go wrong with pytest. PyTest can handle tests at all layers of that pyramid rather effectively. Markers can categorize tests, so you can filter. Test functions and fixtures are lightweight and reusable. Plugins can be added for reporting, code coverage, and even parallel execution. Among all Python frameworks, PyTest is also arguably the most Pythonic. A test automation solution is more than just its core framework, however. Successful automation projects bring together readily available packages rather than developing everything from scratch. Python's standard logging library is a must, especially for feature-level tests. Requests is great for testing REST APIs. And Selenium WebDriver is the mainstay for web browser automation. PyTest also has integrations with other popular frameworks like Flask and Django, if they would be appropriate for your project. Great advice, Andy, Amanda says. This will help me get started. So, Amanda goes back to Bamboozle, and she starts writing tests in Python using PyTest. She found it was pretty easy to get started. Learning curve was pretty low. Taking a pyramid approach, she starts by beefing up the existing unit tests at Bamboozle. And then she moves on to using requests for REST API tests and Selenium WebDriver for web UI testing. She puts the test code in the same repositories as the product code so that they are version controlled together. However, not all is well in paradise. Oops. After writing a number of tests, Amanda discovers some frustrations. She meets up with Andy for bubble tea to pick his mind. Andy, she asks, how do I avoid duplicating so much code in my test automation? So many of these test steps are the same, but with minor tweaks here and there. How can I avoid this rampant code duplication? Code duplication is code cancer, Andy replies. Have you heard about property testing with Hypothesis? It could help you with unit testing. Hypothesis automatically runs tests against a wide range of scenarios, so you don't need to hard code. Also, to avoid duplication with feature tests, try using Gherkin with the pytest-bdd plugin. You can write scenarios in plain language using given, when, then steps that are then glued to Python functions to execute the steps. Steps can be reused by different scenarios. Gherkin also helps you focus on the intended behavior each test covers instead of implementation details. Finally, try using the screenplay pattern to model your web and service interactions as well. I'll definitely check out Hypothesis and pytest-bdd, Amanda says. I think there were talks about them at PyCon 2018. Now here's another question for you. How do you handle test data? My unit tests use PyTest monkey patch feature to mock data, but I'm really struggling to find good ways to manage data in the Bamboozle systems for my above unit testing. Test data is definitely hard to maintain, Andy replies. Try to keep test data to a minimum as much as possible. For most tests, data needs are actually pretty small. Tests should set up and clean up whatever they need in fixtures, such as database records or settings that are custom for that test. Some data, however, like user accounts, are expensive to prepare on the fly and should probably be handled outside of tests. For that, it's best to write scripts or tools that can run before test suites run to prepare the system, and then periodically be run to clean up the system, whack it, get rid of old stuff, and refresh it. Why you would want to do that? Well, sometimes tests can be damaging to your system. They might blast something because something went wrong, either from the automation code or from a feature bug. That makes sense, Amanda says. I've also been storing inputs like URLs and usernames in local config files, so they aren't hard-coded into the test code. Thumbs up. Awesome, Andy replies. That's great. You may also want to consider using some sort of key management service, like AWS KMS or Azure Key Vault. That way, your passwords will be secure and your config files won't go stale. So Amanda goes back to Bamboozle again, and she uses what she learned to improve her test project. It becomes her full-time work, and she transitions the unit test work to other developers so she can focus exclusively on feature-level testing. She does so well that her team keeps asking for more and more tests. Despite training other developers to help write tests, she becomes buried by the backlog. Oh, crap. There we go. Amanda takes a step back and asks herself, what tests should we automate? Her answer is simple. Automation is expensive, so we should focus on return on investment. Amanda writes guidelines for her team to avoid getting crushed by an impractical 100% goal. She recommends automating happy paths for core features that will need to be run repeatedly. She recommends avoiding things like edge cases and one-off checks and visual things, because those would be much easier for a subject matter expert to check manually than to attempt to automate. Amanda also recognizes that these rules are not necessarily universal, but rather guidelines for her team given their context. Even after narrowing down the scope of the tests to automate, the number of tests is still quite large. Amanda's team has hundreds of feature tests that will balloon to thousands in the coming year. The service level tests take about 10 minutes to run, and the web tests are now taking over an hour to run. It's no longer practical for the developers to run these tests on their local machines. So Amanda calls a meeting with her friend, Otto the Panda. He's another developer at Bamboozle. Amanda asks, how can we reduce the burden that automated testing puts on the development process? How can we reduce the burden of testing on development? Otto replies, it would be really nice if we could run these tests as part of a continuous integration pipeline. Then, every code change I make as a developer will automatically have its tests run for it. The only problem is, those tests are still going to take a long time to run. Amanda has a thought. What if we run tests in parallel using pytest-bdd? It could plug directly into our existing framework. Parallel tests would be hard on our laptops, but they would be easy to run in some sort of cloud compute service, where we can scale up much more easily. I can make sure that the test code is thread safe and would have no collisions, such as web logins. Thankfully, PyTest fixtures can help us do that setup and teardown safely and cleanly. And if the burden for web testing is still too much, we could offload web browser testing to a platform as a service, like Sauce Labs or BrowserStack or cross-browser testing. That would be awesome, Otto replies. We also need to make sure that feature owners are alerted whenever their tests fail. That way they can triage the failures immediately. That fast feedback loop. So, Amanda and Otto team up to make it happen. Amanda updates the automation code to use pytest-bdd, and Otto adds new jobs to their existing Jenkins build server for running test suites. They also set up report portal IO to be their test result dashboard. Tests complete in a fraction of the time, and developers get failure notifications immediately. However, adopting true continuous integration brings unforeseen consequences. More test runs means more issues uncovered. You get nothing for free. While most tests run fine, some start failing intermittently. There are 4 common reasons why. First reason is that the feature under test may have a tricky bug. Hard to deduce, only comes up once every 10 times. They can be really, really hard to nail down. Another reason could be the feature under test was updated without updating the test for the feature. So it's not necessarily that there's a bug, it's that now you're just out of sync. A third reason could be the automation didn't handle an unexpected condition. Some exception bubbled up out of nowhere, the automation didn't know what to do, so it puked. That sucks. And the most dreadful case for our friend Amanda, the automation code itself might have a bug. Bum, bum, bum. Test automation is software, right? Software is prone to bugs. Hence, your tests may have bugs in them. Oh, that one hurts. Unfortunately, these have consequences. The failures leave a bad impression on the team. Some of Amanda's team members stop triaging test failures. Some even go so far as to suggest that they should just skip the tests because they don't see them adding value. This happens in the real world. So Amanda doubles down. How can we make tests more reliable? She asks herself. A couple things. First, she realizes that continuous integration is the production environment for tests. I'll say that again. Continuous integration is production for tests. And it should be treated as such. Test code should undergo the same best practices. There should be coding standards. There should be code reviews. Shared test framework components should also have unit tests. Secondly, Amanda discovers that the most common points of failure are remote procedure calls and race conditions. She tunes the test framework to have appropriate timeouts, immediate retries, and helpful failure messages when any of these problems arise. She makes it automatically correct what it can and safely abort with an informative message when it can't. She also looks into contract testing to avoid network problems. Contract testing, if you haven't heard of it, with a framework like PACT, will create mocks or contracts of your service calls to use for testing integrations. Service providers will fulfill that contract so that other consumers for testing can just use the mocks for speed and reliability. Third thing Amanda looks at, she reaches out to her team members for better collaboration. They institute better processes for flagging feature changes that will affect tests and for being gracious on both sides when failures happen. It's not a blame game. As a result of these three major things, automation becomes more reliable and confidence in the test is restored. By this point, the automation solution has matured. New tests are added every sprint, and they provide fast feedback to development. As Bamboozle continues to grow, they need to hire more people. That's the good kind of problem to have. Since Amanda's time is already maxed out, her manager asks her, what should we look for when trying to hire software engineers and test? That depends on our need, Amanda replies. The word test or QA in someone's title can be misleading. Some people are developers at heart who will simply apply their development skills at the problem of test automation. They can build frameworks and solutions and tools from the ground up. Others are automationeers who are good at plugging into existing frameworks and just cranking out new tests. Others still aren't necessarily good at programming, but they have a knack for manual and exploratory testing. Another factor to consider, she continues, is role separation. Do we want to have a dedicated team of developers separate from a dedicated team of testers or software engineers and test? Or do we want developers to take on test responsibilities? We break down those silos. Each way has its pros and cons. I think it's best to have a small core of expert software engineers and test who can build and maintain the solution and support developers who start to write their own tests. And that's Amanda's automation journey. Woohoo! There's so much more to be said on this topic. I can only cover so much in half an hour. But at least her story can give us a roadmap for how we build test automation solutions. I've put some resources here if you want to continue learning. I've got some articles on my blog about parallel testing, PyTest, and why Python is a great choice for test automation. There's also some communities like the PyBytes community or Ministry of Testing that are great resources, people you can reach out to. They put good info out there. And also, if you want to learn more about PyTest, I recommend this book, Python Testing with PyTest. Good book. I'll have it with me if you want to thumb through it. And also, just for reference, I splattered all the different Python packages that I've mentioned during this talk, things like request, hypothesis, pytest-bdd, just so that you can look them up later. And so, thank you for your time today. I'll be out in the hall for more questions. Please follow me on Twitter at my handle, AutomationPanda, and I continue to write resources on my blog, automationpanda.com.